Previously, we covered the core foundations. Now, in Part 2, we tackle what you actually see when watching a rocket launch. Part 2. Why rocket launches sometimes create spectacular sky spirals. Last time, we covered the basic anatomy of what you see during a rocket launch. But there's one phenomenon that transforms an ordinary launch into something truly extraordinary. Why do some rocket launches create those spectacular corkscrew trails that look like they've been painted across the sky? I'm your host at Orbital Dispatch, and in this second part of our series on what you actually see when watching rocket launches, we're diving into the science behind those mesmerizing sky spirals. The answer lies in a perfect storm of atmospheric conditions, rocket design, and timing. Let me break down exactly what's happening up there. The altitude factor. These spirals don't happen at ground level. They typically appear when rockets reach the upper atmosphere, usually above 100 kilometers altitude. At this height, the air is incredibly thin. We're talking about pressures less than 1/1,000,000th of what you experience at sea level. When rocket engines fire in this near-vacuum environment, their exhaust plumes expand dramatically. What would be a narrow jet of flame at ground level becomes a massive, billowing cloud of gas and particles. This expanded plume acts like a giant brush, ready to paint patterns across the sky. Wind shear creates the twist. Here's where it gets interesting. The upper atmosphere experiences significant wind shear, different layers of air moving at different speeds and directions. As the rocket climbs through these varying wind layers, its exhaust plume gets twisted and stretched. Think of it like squeezing toothpaste while someone slowly rotates the tube. The rocket provides the steady stream of exhaust, whilst the rotating wind layers create that distinctive corkscrew pattern. Twilight Effect. But why do these spirals look so dramatic? It's all about timing and sunlight. The most spectacular spiral displays happen during twilight launches, when the rocket is in darkness at ground level, but reaches sunlit altitudes above. The rocket's exhaust contains water vapor and other particles that reflect sunlight brilliantly against the dark sky. It's essentially creating its own temporary aurora, backlit by the sun whilst you're standing in shadow below. Earth's rotation adds another layer. There's one more factor at play that most people don't consider: Earth's rotation. During longer burns, particularly for second-stage engines, our planet's rotation beneath the rocket adds a subtle but measurable twist to the exhaust trail. This Coriolis effect is the same force that influences weather patterns and ocean currents. For rockets, it contributes to the spiral's overall shape, especially during extended engine burns that can last several minutes. Why some launches don't create spirals? Not every launch produces these patterns. Daytime launches often create trails that are barely visible against the bright sky. Launches that occur entirely within the lower atmosphere won't have the right conditions, and rockets following certain trajectories might not encounter the specific wind shear patterns needed. Predicting the show. If you want to catch one of these displays, look for evening or early morning launches, particularly those heading to higher orbits that require longer upper stage burns. Space agencies don't typically predict spiral formation in advance. It depends on real-time atmospheric conditions that can change by the hour. What this means for launch watching. These spirals represent something remarkable. They're visible proof of the complex dance between human engineering and natural forces. Every spiral is unique, shaped by that moment's specific combination of atmospheric conditions, rocket trajectory, and solar illumination. They remind us that rocket launches aren't just demonstrations of technology. They're interactions with our planet's dynamic atmosphere, creating temporary art installations that can be seen across hundreds of kilometers. Next episode, Part 3 explores the next key question. If you found this breakdown useful, subscribe for more clear explanations of space science without the sensational headlines. That is part 2 of what you actually see when watching a rocket launch. In part 3, we explore the next key question. Subscribe so you do not miss it.